Good morning. Suppose we have a circuit like this and we want to use superposition method to calculate the current flowing in this branch. Superposition says if we have n sources in a circuit, we can divide this circuit into n circuits where only one source working. The others are transformed into a short circuit if it's a voltage source, and to an open circuit if it is a current source. So the current IR2 in this branch, for example, will be the algebraic sum of IR2 prime plus IR2 2 prime and IR2 3 prime. So first of all, let's take this circuit first and calculate this current, and then this current using this source, and later this current using the current source. First of all, let's take the first source here, this circuit, and let's try to resolve this circuit and calculate I2 prime. Here we need to calculate the equivalent resistance of this circuit, which is R1 plus R2 in parallel with R3. So it's equal to 36 plus 20 times 30 over 50. Do I have the calculator? Well, I think it's here, it's 12. It means that it's 36 plus 12, it's 48 ohms. This is 48 ohms, the equivalent resistance. Now we can calculate the current that is flowing here, IR prime, 1 prime, which is equal to V1 over the equivalent resistance. V1 is 72 volts, so it means that the current I1 is 1.5 amps. Now we are going to use the current divider. I will remind you a little bit about what is the current divider. Current divider is when we have two parallel or three parallel resistances and we want to calculate their current. This is I1, I2, and we want to calculate these currents in function of the main current, knowing their resistances. For example, here we can say that the voltage is equal to the equivalent resistance times the current. The equivalent resistance, as you know, it's R1 times R2 divided by R1 plus R2 times I, knowing that I1 is equal to V over R1 and I2 is equal to V over R2, we can say that I1 is equal to this divided by R1. We're left with R2 over R1 plus R2 times the main current, and here it's R1 over the sum, the resistances times the current. Okay, now we can extend this to three resistances in parallel. Three resistors in parallel. I won't develop it, but I will give you the equation for calculating these currents. Equivalent resistance, as you know, or equivalent, is R1 times R2 times R3 over R1 times R2 plus R2 times R3 plus R3 times R1. So it means that the current, I can give you the formula, is R2 R3 over the sum of the RR, this one. And if it's I2, it will be I1 or R1 R3. If it's I3, it will be R1 R2. We're going to use the current divider in all this, in these calculations. Here now we can calculate IR2 prime. We have chosen this sense, this direction as positive, so if the current flows this side it's positive, and if it flows the opposite like here it's negative. So R2 prime is equal to the main current times R3 over R2 plus R3, and this is equal to R3, which is equal to 30 divided by 50 times 1.5, and is equal to 0.9 amps. So we can write here that it's 0.9 amps. This is IR2. Now we go to the second circuit, which is here. Same thing, we calculate the equivalent resistance is R3 plus R1 times R2 over R1 plus R2. And this one R3 is 30 plus R1 36 times 20 over 56. And this gives about 42.857. We write it here, 7 ohms, and we can calculate main current IR second or 2 prime, and is equal to V2 over RE. This is 90 over 42.857, and this is equal to 2.1 amps. And from here we can calculate R2 second, which is equal to main current times R3 over not R3, R1 over R1 plus R2 times this one. R1 is equal to 36 over 56 times the current we have calculated here, and it's about 1.35 amps. We calculated it, we put it here, and now we calculate IR3 prime. We take, here is the circuit, and we use the current divider. As I said, for 3 resistors, we can say that this will be negative because it's flowing the other direction. 3 prime is equal to current flowing here, it's R1 times R3 over times I1, here R1 R2 plus R2 R3 plus R3 R1, and this will give R1 and 236 times R3 30 over 36 times 20 plus 20 times 30 and plus 30 times 36, I think, and times 3, and this will give us here at the numerator 1090 and 80, I think, and here will give 2040 400 if you have not mistaken, times 3, and this is with a sign of minus because it's flowing the other way, and it's what's the value, is it minus 1.35, and we put the value that we have calculated here, minus 135, and the result is 0. Excuse me, I should have written 0 point, and the result is 0.9 amps. And that's it, I finished. And this is, as I said, superposition method. Position method. And thank you very much.